Okay, so this video is going to kind of talk about the basic properties of exponents. So mainly what we're going to be doing is simplifying, and I'm going to use variables with that. So these are all the different properties that we've learned, and I'll kind of write them as we go through them. Okay, so here's a property. So if we had something like x squared times x to the third. So notice in this problem that these two terms have the same base, x is the base, okay, and that you're multiplying these two terms together. So when you're multiplying and you have the same base, you can add the exponents. So really, what I have is x to the 2 plus 3, which equals x to the 5th. Okay, so when you're multiplying two terms together, x squared times x to the third, and they have the same base, which the base is x, you can add their exponents. So I know, and it's kind of weird because, well, wait, you're multiplying. Why are you adding the exponents? That's the way exponents work. So when you're multiplying together, you add the exponents. So here's another way you could look at it. You could write it like this. So I have x squared, which really means x times x, right? And then x to the third means x times x times x, right? So I have two x's from here, and I have the three x's from here. How many x's do I have in total? 5. So x to the 5th. So that's why that theory kind of works, because we have x squared times x to the third, and so I have all those x's together, and rather than having to separate them out every time, you just add the two exponents together. So 2 plus 3 equals 5. Okay? So, and there's another kind of property similar. So when you're multiplying, you add the exponent. So if I had this, x to the 5th divided by x squared. So notice, just like in the top problem, I have the same base, so x and x, but I'm dividing this time. So remember, when it's a fraction, that means division. So when you're dividing, that means you subtract the exponents. So this would be 5 minus 2, which equals x to the third. Okay? So it's, again, the way you can kind of look at this is, if I have 5 x's on top, so 1, 2, 3, 4, 5, and 2 on the bottom, 1, 2, I can cancel out some of the x's, because I have an x here and an x here, and all I have left are 3 x's, so that's why it's x to the third. But rather than having to separate it all out and do that, we just have this theory that, or property of exponents, where if you're dividing two terms with the same base, you subtract their exponents. So it's x to the third. So those are the multiplicative properties, or the product properties, okay, and the quotient property. All right, and here's another one that I want to kind of introduce to you. All right, so if we had x squared over 2y to the third, all, we'll say to the 5th power. Why not? Okay, so if I have this kind of problem, so I have a exponent, here I'll go ahead and underline it here, I have an exponent raised to another exponent. So a power raised to a power. If that happens, what I actually do is multiply those two exponents together. So an exponent raised to another exponent, you multiply them together. The same thing applies for the exponent down here, 3. And even though it's not written, look at this 2. The 2 actually has an exponent as well. It has an invisible 1. So you multiply the 5 on the outside of the parentheses to all the other exponents inside the parenthesis. So I would have x to the 10th over 2 to the 5th, y to the 15th power. Okay? And then, of course, you look for the proof properties we just talked about. Are there any other things we can simplify? That would actually be my final answer. So we just have to distribute the outer exponent to all the inner exponents. It would kind of like be doing it this way if we were to rewrite it this way. So x squared 5 times, so that would really be x squared times x squared times x squared times x squared times x squared, right? Because x squared 5 times is that. And on the bottom, I have 2 5 times, so 2 times 2 times 2 times 2 times 2. And then y to the third 5 times. So y to the third times y to the third times y to the third times y to the third. See how boring this gets? I mean, really, you could be eating a burrito or something. All right, so, and using the theory that we just talked about in the top left, since they all have the same base, I can actually add all those exponents together. So 2 plus 2 plus 2 plus 2 is 10. And then, remember all these have invisible 1 exponents. So 2 to the 5th goes here. And then 3 plus 3 plus 3 plus 3 plus 3 is 15, where that comes from. So, what we decide to do is, when an exponent is raised to another exponent, we multiply the 2 exponents together. All right, so those are the basic properties of exponents. And I'll show you some more examples of actually doing some problems where you would use these properties.